Today I will teach you about momentum. Okay, so what is actually a momentum? Okay, so every object, right? Every object that has a mass, okay, and also have a velocity, okay, it must have the momentum. Okay, it must have a momentum. So every object that has a mass and velocity, okay, so it must have the momentum. Okay, so because since so basically, right, basically, so we can say that, all right, so every object that moving, okay, is having a momentum, right? So this is the example. So let's say a softball player, right, must wear a glove to catch a hard and fast moving softball. So a slow moving softball is much easier to catch, right? Why? Okay, so fast moving softball means they have the high velocity, right? Okay, so when they have the high velocity, and you already know that actually the momentum is depend on the mass and velocity. So since it has the high velocity, it will have the high momentum. Okay, so let's say in the exam, right? Let's say in the exam they ask you, right, what is the meaning of the momentum? Okay, so momentum is actually, okay, mass, alright, multiply by velocity. Okay, or you can put in formula mv, and then the unit is mass is in kg, right? Velocity is ms negative 1. Okay, so this is the meaning of the momentum. Okay, and what is the formula for momentum, and also the unit for the momentum. Okay, so for this one, why it's hard for the softball player, okay, to catch a hard and fast moving softball? Because it has a high momentum. Okay, and then let's say we have another example. Okay, so you have to compare the velocity and the time it takes for the lorry and the car to stop. Okay, which is harder to stop? Okay, so for this one, okay, you got a car, okay, and also a lorry. So of course the car, they have the low mass if you compare with the lorry, right? And then the velocity here is same, right? Both move with the same velocity, that is 30 ms negative 1. So this one, the only change, the only difference, right, between the lorry and also the car is actually the mass, right? So which one is harder to stop? Of course lorry, right? Of course lorry. Okay, so you can see the time here. Okay, the time for the car to stop is much lower compared to the lorry. Okay, basically actually the momentum is also can be connected to the inertia, right? Because the inertia also is depend on the mass, right? So let's say if the object has the high mass, means it's high inertia. Okay, so high inertia means it's more difficult for the object to stop. Okay, so it's actually a kind of connected with the inertia also. Okay. Alright, so let's say we go to move on to the next slide, okay, to study how the mass and velocity of an object, alright, influence the effect of the stopping the object. Okay, so we have two example here, okay. So this one they use a golf ball with different height, okay. So when it's different height means this one they have a different velocity, okay, because we already know that v is equals to s over t, right? So when the s is higher, the velocity is also higher. So for this one, the a has a lower, okay, lower velocity, okay, and this one has a high velocity. Okay, so first question is said, which golf ball hit the plasticine at the highest speed? Okay, this one I already explained, since the displacement or the distance, okay, between the two golf, b is higher. Okay, so means the velocity for b is higher. Okay, so ball b has a higher speed. Okay, so we move on to the next question. Compare the depth of the cavities made on the surface of the plasticine by the falling golf ball. Okay, of course, right, for diagram B, right? For diagram B, they have uh, the depth of the cavities is much higher. Okay, since they have the high velocity. Okay, so ball B has a deeper cavity. Alright, and then the next question, which golf ball has a bigger effect of stopping? So of course B, right? So ball B. Okay, so this one if we connect to the momentum, right? We already know that momentum symbol is P, right? So P is equals to mv. Okay, and we already know for B they have the high velocity here, so means the momentum also high. So means it's harder for the ball B to stop, okay, to stop and also to start moving, right? Okay, so this one the answer is ball B. So this is the connection, right? Alright, for number 2, right, to compare the effect of stopping two objects of different masses moving at the same speed, right? So which ball has a greater mass? Okay, for if you compare the golf ball and the ping pong ball, of course the the golf ball have a greater mass. Okay, golf ball, right? And then which ball falls and makes a deeper cavity on the surface of plasticine? So this one also golf ball. Okay, and then which golf ball has a bigger effect of stopping? So this one is actually which ball, right? Not which golf. So this one is which ball has a bigger effect of stopping? Of course, golf ball. Okay. So what's the conclusion here? Okay. So state how the effect of stopping object in motion depend on mass and velocity of the object. Okay. So here means when the effect of the stopping object is higher or bigger. Okay. If the mass and velocity is higher. Okay, so mean it's hard for the object to stop if the mass and also the velocity is higher. Okay, and then you have to relate the effect of stopping object with momentum. Okay, so the greater the momentum, okay, the greater the effect of stopping the object. Means if the momentum is higher, it's very hard for the object to stop moving. Okay, because it's depend on the mass and also the velocity. Okay, so for the object have the high mass, okay, it is hard for the object to move, to stop moving. Okay, and also if the object has a high velocity, it also hard for the object to stop moving. Okay, so this is the two factor that affecting the momentum. Okay, the mass and also the velocity. Okay, so every moving object has a momentum. Okay, this one I already told you earlier, right? So every moving object has a momentum. So any object, of course, all the object has their own mass, right? So that one we cannot argue. Okay, and then the velocity, so it's depend on the movement of the object. Okay, so since if they has the high velocity, means they will have the high momentum, right? And momentum can be thought as a tendency of an object to keep on moving with the same speed and the same direction. Okay, so this one I already told you. Okay, because we know the inertia. Okay, is the what's the meaning of the inertia? The tendency of an object, right, to keep moving. Okay, if you're moving in the straight line, it will still want to keep moving in a straight line. Okay, so it same like this also. Okay, so momentum also is the tendency of an object, okay, to keep on moving with the same speed in the same direction, because it's quite connected, because both is depend on the mass, right? Both depend on the mass. So high mass, high inertia, and also for the momentum, high mass, high momentum. Okay, and we already know for the lorry and for the car to stop, of course the lorry they have the more difficulties to stop if you compare with the car. Okay, so what's the difference? The difference is the mass. Okay, so momentum and inertia are quite connected. Okay, momentum often indicates the difficulty of moving object has in stopping. Okay, so momentum is the measure of how hard it is to stop an object. Okay, so a fast moving car has more momentum than a slower one of the same mass. Okay, so this one you have to be careful, right? So let's say they're using two objects, so you have to see what is the difference, whether the mass or the velocity is different. Okay, so if they use a same mass, means they must have a different velocity. If they use the same mass, means same mass, different velocity. If same velocity means different mass. Okay, this is only two factors that affecting the momentum, mass and velocity. Right. So according to a Newton, okay, the object with less momentum is easier to stop and give less impact in the collision. So let's say you have a small accident. Let's say you're riding a bicycle, okay, and then you hit something, okay, and you compare. Let's say, if we ride a car and we hit something. So which has the high impact? Of course, car, right? Because of what? Because they have the high momentum. Okay. Why? So maybe it's different between the mass and also maybe different depends on the velocity also. Okay, so we have to look, okay, what is the situation there. Okay, so a baseball player must wear a glove to catch a hard and fast moving baseball because the ball has a big momentum. Okay, in moving in a very high velocity, and it is difficult to stop the ball and will give a larger painful impact when it hits the player's hand. So why they have to use a glove? Okay, because it's actually to absorb the impact, right? Absorb the impact of the ball. Okay. Later you will learn about the impulsive force. So this is quite connected with the impulsive force too. Okay. Okay, so now we are going to define, right? So we already see what is the connection, what is the factor that affecting the momentum. Okay, what is actually the momentum? Okay, what object? If we can say that what object, what is the characteristic of the object? Yes, if you want to say it has a momentum. Okay, of course it must have a mass and it must be moving, right? Okay, so we define the momentum. So momentum is mass multiplied by velocity. So in exam, so if ask you about the meaning of momentum, remember in exam they will ask you the meaning of the physical quantity. Okay, so you have to remember all the physical quantity that in physics. Okay, so before this we already learned about the displacement, velocity, speed, right? And also we learn about the inertia, alright? And we also learn about the first Newton law, that is actually an inertia. Okay, and we already learn okay, many physical quantity in physics, right? So that one you have to remember. Okay, so maybe later I will give you a list, right? A list of the physical quantity that you need to remember. Okay, so it's easy for you to start from now. Okay, later then from 5 we're having a hard time because too many things to remember, right? Okay, so this is the momentum. Momentum is mass multiplied by velocity. So remember, if you do want to define, if you want to give a definition, you cannot give in formula. Okay, cannot give like this. So this is wrong. Okay, so you have to define for every symbol, okay, that you use. So let's say this one, M is a mass. So you have to put in the word. So mass multiplied, okay, by velocity. So this is the correct one if they ask you about the definition. But remember, not all the definition can use the formula, okay, as the definition. Not all the physical quantity can be used, okay, the formula as a definition. So sometimes you have to use in another words, okay. So that one we will discuss more later, okay. So but for this one, yes, it's okay for you to use the formula as a definition. Okay, so momentum is equals to the mass multiplied by the velocity of the object. Okay, and this is the vector quantity, means for the vector it has a direction, so and also have a magnitude. Okay, so if you want to calculate the momentum, okay, since a mass multiplied by velocity, right? So the velocity you must consider the direction. So whether it move forward or move backward, okay, you have to put the positive and the negative sign. Okay. Okay, let's say we have this one, example 1. Okay, so in a football game, a player of mass 70 kg is moving with velocity of 4 meter per second, and the other player of mass 75 kg is moving with 3 meter per second toward each other. So calculate the momentum of the both players. Okay, so you have to calculate, let's say for the momentum, okay, for the player, the first player 70 kg, right? So you just use P is equals to mv. And remember, okay, please put the formula here. Okay, put the formula here. Every calculation you do, okay, you must put the formula first, then you just substitute. Okay, so the mass is 70, the velocity is 4. So you will get 280. Okay, and then the unit is kg ms negative 1. Okay, this one is 70 kg. Okay, and then another player, okay, they move in the different direction, right? So this one, they move to the right, and this one move to the left. Okay, so remember the one that move to the right is actually is the positive. Okay, the sign must be in positive. Okay, if you move in the left, this one the sign must be negative. Okay, so for the 70 kg, the V we use the positive sign. Okay, so you don't need to put that. Okay, but for the 75 kg, you have to put the negative sign. See, we move in the different direction. So that's why we said the momentum is a vector. Okay, so this one is 75, you multiply by negative 3. Okay, this one most of you will get confused. Okay, you will not put the negative. Okay, so that's why I say you have to read the question carefully. Okay, you have to consider all the directions. You have to know whether the quantity is a scalar or vector. If vector, you have to need to consider direction. If the scalar, you just ignore it. Okay, so this one negative 25 kg ms negative 1. Okay, so and then for example 2, so the granny, right? Granny, the mass is 80 kg, okay, whizzed around the ring with a velocity of 6 meter per second. And then she suddenly collide with her grandson, okay, boy, that has a mass of 40 kg, who is at rest directly in her path, okay. So calculate the momentum of granny and the boy. Okay, so for this one, okay, they move in the same direction. Okay, both move to the right. Okay, so mean you don't need to consider whether it's positive or negative. Okay, so the granny, they have the mass of 80 and the velocity is 6. So you just multiply. But remember, put the formula first. Okay, so you got 480 kg ms negative 1. Okay, but for the momentum of the boy, okay, so you just, because it's at rest, right? So means the velocity is 0. So when you multiply, we get 0 kg ms negative 1. Right. Next part. Okay. This is a very important one. Okay. So principle of conservation of momentum. Okay, so the total momentum of the system, okay, will remain constant, okay, if there is no external force X on the system. Okay, so let's say for this one, okay, for the rocket, right? So the total momentum before, okay, before it going up, okay, so it's actually equal to the after it's going up. Okay, so that one is the total momentum of the system will remain constant if there is no external force X on the system. Or we put it, okay, in other words, okay, that is total momentum before collision is equals to the total momentum after collision. This one you must remember. This is the very important part. Okay, means the total momentum before collision equals to the total momentum after collision. Okay, but if you put momentum before collision equals momentum after collision, it's wrong. Must have the word total. Okay, so later I will show you why we need to put the word total, because sometimes in the exam paper they will just put momentum before collision equals to momentum after collision to confuse you. Okay, but that one is actually wrong, because we know the principle of conservation of momentum. Before and after, the total momentum must be same. So they just take out the total. Okay, they want to see whether you can understand actually the principle of conservation of momentum. So must have the word total. Okay, so when we see about the elastic and inelastic collision, you will see why you need to put the word total. Okay. Okay, to study the situation involving principle of conservation of momentum. Right, so the first one, the situation 1. So diagram shows two brothers are skating. Okay, the elder brother move and collides with younger brother who is at rest. So this one is same situation as the question involving the granny before, right? So what is the movement after the collision? Okay, so what happened to the speed? Whether the boy will still at rest, or maybe the elder brother will become will stop moving. Okay, so we see about that. Okay, and then what is their movement after the collision? Okay, what happened to the speed of the elder brother? It will decrease. Okay, it will decrease. Okay, but the speed of the younger brother, okay, for the younger brother, it will start moving, right? Okay, it will start moving. Okay, so it will increase. Okay, since before the younger brother is at rest. Okay, so when the elder brother move and collides with the younger brother, so the younger brother will start to move. Okay, it will start to move. So now the speed of the brother will increase, but the speed of the elder brother will decrease. Okay, and then the momentum of the elder brother decrease, but the momentum of the younger brother increase. Why? Because you already know the momentum is actually P is equals to mv. Okay, so just now before this, the younger brother, the V is 0, right? So when it start moving, okay, after it collide with its brother, okay, it move, right? So now it has a velocity. So if you compare before, the velocity is 0, means the momentum is 0 also. Okay, and now when the elder brother collide with the younger brother, now the younger brother start moving. So now it has a velocity. So means from 0, now it has a momentum, right? So the momentum of the younger brother increase. Okay, but for the elder brother, the speed, the speed become lower, right? So the speed become lower means the momentum also become lower. Okay, so that's why the momentum of the elder brother decrease, but the momentum of the younger brother increase. Okay, now we have a next situation. Okay, so let's see for
1,
this.
2, 3, 4, 5, 6, 7. 7 coins. 1. 1. Let us do it 2. 2. 2. 3. 3 and 2. 1, 2, 3, 4, 5, 6, 7. 1
Okay,
coin.
alright. So you already see the video. Okay, you already see the video. Okay, so flick a 20 cent coin A directly to another 20 cent coin B. So this one they use only 2 coin, but this one they use a 7. Okay, 7 coin. Okay, so what happened to the motion of the both coins after collision? Right? So what happened to the coin A? So the coin A will stop move. Okay, but the coin B will start moving. Okay, coin A will stop move, but the coin B it will start moving. It's the same as the video just now. Okay, so when he flicks the first coin, right? So the rest of the other coin will stay stationary, and also the coin A also will stop, right? And only the at the end here, the coin at the end here will start moving. Okay. So what happened to the momentum coin A after collision? So after the collision, it will decrease. Okay, why? Because this momentum is transferred to coin B. Okay, like this also, like this one also. Okay, so the first, it flicks the first coin, right? So when it flick the first coin, the momentum here will be transferred, okay, until the end. Okay, so at the end here, okay, the coin at the end here, it will start moving. Okay, but the rest it will be at rest. Okay, only the first one, okay, the first one will stop, okay, and the momentum is transferred through all the coin here, okay, and it will start moving here at the last coin here. So the last coin, only the last coin will move. Okay, so means the momentum is transferred to point B. Okay, now we have a situation 3, right? You flick a 20 cent coin A and directly to 20 cent coin B and C. Okay, and then you have to describe the motion of all coins after collision. So of course the coin A will stop. Okay, and also the coin B also will stop, but the coin C it will move forward. Okay, so the next question, what happened to the momentum of coin A after the collision? So the momentum will decrease, right? Because it stops. So means V is 0. Okay, so P is equals to mv. So V is 0, the momentum also should be 0. So it will be decrease. Okay, and also it will transfer the momentum to coin B and coin C. Okay, so that's why it's become 0. It's transferred the momentum to coin B and coin C, and the coin C will move, okay, with the same momentum. Alright, so let's move on to the next one. Okay, this is situation 4. So linear momentum conservation. Okay, this is a Newton cradle that have the same mass. So you can see here when the two balls, right, hit another 3 ball here. Okay, only one will stay at the rest while the other 2 will start moving. Okay. Okay, you can see that. Okay. Alright. So this is actually the Newton cradle. So means this one the momentum will be transferred. Okay. So let's say for this question, so a steel ball A is pulled and then released. Okay. So what happened after the steel ball A hits the steel ball B? So the A will stop, B, C, D also will at rest, and but ball E will move forward with the same height as the ball A. Right? Same height as the ball A. So the question here, is still momentum conserved? Is the momentum conserved? Yes, right? Because it moves with the same height. Right? Just now, like we see in the video just now, okay, you try to lift up the ball A, and then you let it go, and you can see at the end there, the ball at the end will move with the same height as A. Okay, so we can conclude that actually when it's the same height means same velocity, right? Because V is S over T. So the height of the A and E is same. So height and A is same means their S also same. So means the velocity also same. Okay, so P is equals to mv, right? So the velocity same, the momentum also should be same. And you already know this. When this video start, it already told you the mass is same for all the ball. So mass here is constant, right? So this one is involving only the velocity and the momentum. Okay, so predict what will happen if two balls A and B and pull are released. Okay, A and B are pulled and released. So means two ball. Okay, you lift up two balls A and B. Okay, but A and B will stop. C will stop, but D, E will move upward. Okay, so this one we can conclude that the momentum is conserved. Okay. Alright, so now is the important part in the collision. Okay, collision. So there are two types of the elastic collision. Two types of collision. The first one is elastic, and the other one is inelastic. Okay, so for elastic, right? So what is the meaning of the elastic? Okay, so let's say you have a two object. Okay, let's say for this one, M1 and M2. Okay, so when M1 and M2, okay, collide with each other, right, the object will move in separated ways, or it will not stick together. Okay, even maybe they move in the same direction, okay, but they not stick together. Okay, so that one is called it as a elastic, right? So let's say it hits, and then it will move in the separate ways, or it move in the same direction but they are not stick together. Okay, that one we call it as a elastic collision, right? Elastic collision. Alright, so motion of both objects after collision. So elastic collision, they will move separately with different velocity. Is the momentum conserved? Yes, the momentum is conserved. We already proved just now, right? By using the ball and by using the coin, okay, we already proved that the momentum is conserved. Okay. Is the energy conserved? Yes. What kind of energy here with the meaning? With the kinetic energy. Okay. So is the kinetic energy conserved? Yes. Kinetic energy is conserved. It means the kinetic energy, the total kinetic energy, okay, total kinetic energy before collision is same as the total kinetic energy after the collision. Okay, so that will be same. Okay, the equation here, this is the equation. What is the M1? M1 is the mass for object number 1. Okay, for object number 1, because when the collision, they need two objects to collide together, right? So means the object number 1, we call it as a M1. Object number 2, we call it as a M2. Okay, so this one is before collision. Okay, before collision. Okay, so and then when it collide, okay, and you already know U is actually initial velocity, right? Okay, so this one means U1 is the initial velocity for object 1. U2 means the initial velocity of the object number 2. Okay, so this one is before collision. Okay, then after it collide, okay, so this is the momentum, okay, after it collide. So after collision, okay, still the mass will not change, okay, of course, okay, but the velocity is changed, okay. So they use the V. So V is actually the final velocity. So the final velocity is actually after the collision, okay. So U, we using it before it collision, okay, before two objects collide, and after the object collide, we use it as a V, right? V1 means the final velocity for object 1. V2 means the final velocity for object number 2. Okay, so for this equation, you have to remember, because in the exam, they will not give you this question. Okay, so M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. Okay, remember just now at the early part, I already mentioned about the principle of conservation of momentum. Okay, I told you that the total momentum before and after the collision is same, right? And I told you why. I will explain why you have to put the word total here. So you can see here, right? This is the before collision. Okay, so before collision, we add the total of the momentum of two objects, right? Okay, we sum up the two momentum of two objects. Okay, so that's why we have said we have to have the word total here, because here you have to sum up, okay, the momentum before collision and the momentum after collision. So that's why you have to use the word total momentum. If you use the word momentum only, means only one momentum involved here. Okay, so must have used the word total. Okay, so I hope you understand about elastic. So remember, elastic, two objects collide, okay, it will move separately, okay, or if they move, okay, in same direction, okay, if they move the same direction, okay, it will move in the, it will not stick together, it still separate, okay, so that is elastic. Okay, what is inelastic? Okay, for inelastic, you can see here the object is stick together. Okay, so in exam, how do you want to know, teacher? How you want to know that whether it's elastic or inelastic? So it's easy. If they're inelastic, they will put like plasticine. Okay, plasticine at the back here. Okay, so means after it collide, it will stick because of the plasticine. Okay, or you have to search the word. Okay, you have to search the word move together. move together, or you can say stick together. So if they mention this word, you know this is the inelastic collision. Okay, so for inelastic collision, motion of both objects after collision move together with same velocity. Okay, of course, then now they collide and then they stick together. Okay, now it's like it become one object, right? Okay, when it collide and it become let's say like this. Okay, so it collide and then it stick together. Now of course it only become like one object here. Okay, so of course it move with the same velocity. Okay, so is the momentum conserved? Yes, the momentum is conserved. Whether elastic or inelastic, the momentum will be conserved. Is the energy conserved? Yes, energy is conserved. Okay, but is kinetic energy is conserved? No. For inelastic collision, the kinetic energy is not conserved. Why? Because just now you have two velocity, right? Before the collision, we have a two velocity. Okay, two initial velocity. So after it collide, now it become only one velocity. So of course there is change in velocity then. Okay, it will change in velocity before and after the collision. Right? So this one, I hope you still remember. You already learned in Form 3, right? The kinetic energy is half mv squared. So if the velocity change, the kinetic energy also will change. Okay, so just now when only two objects move with two velocity, now after it collide, only one become one velocity. So means the energy, the velocity now they have a change in velocity. So when the velocity change, the kinetic energy also will change. Okay, so that's why the kinetic energy is not constant. Okay, and this is the formula. Okay, m1 u1 plus m2 u2. Okay, same, m1 is the object for number 1, m2 is the mass for object number 2. Okay, and this one is a before collision. Okay, before collision, this is after collision. Okay, so after the collision, the object 1 and 2 it combine. Okay, combine and become one object. Okay, and you move it to same velocity. Okay, so this one also you need to remember the equation. Okay, so activity number 3. Okay, to study the principle of conservation of momentum for explosion. Okay, blow a balloon, then release the balloon. So what happened to the balloon? Okay, so let's see this video first. So when you release the balloon, what will happen? It will go up, right? It will go up. Okay, this is before COVID, right? So there's a lot of activity that can be done. Okay, but now I'm not sure. Okay. Alright, so after that we release the balloon. So what happened to the air in the balloon? Okay, the air moved backwards, right? So this one is actually same as the principle of rocket. Okay, engine in the rocket. Okay. Alright, so when you release the balloon, okay, the air will move backward. Okay, but for the rocket, they will release the high velocity of hot gas, right? Okay, so then it move, then according to the principle conservation of momentum. Okay, when the forward, it will produce forward, okay, forward force, right? Due to the principle of conservation of momentum, they will produce the forward force, and then the rocket will go upward. Okay, since you know the hot air gas will move downward, so it will produce one force, right, move forward. Okay, and then the rocket will move. Okay, so we go upward, right? So that one we'll see later. Okay, the explanation. So for the balloon here, the air will move backward, right? So the air will come out, okay? The air will come out downward, okay? And the balloon will go upward, okay? So here the balloon move forward, okay? So this is the principle of conservation of momentum. The momentum of the air that move backward, okay, or move downward here, okay, is equals to the momentum of the balloon that move forward. Okay, so this is the principle of conservation of momentum. Okay, same also. Okay, so this is situation 2. So let's say we do it in this one in the lab. Okay, so stick two trolleys A and B with the same mass together. Okay, hit the vertical road on the trolley, so the spring road will extend and push the two trolleys away from each other. So you hit here, there's got a spring here. Okay, they got a spring here, and uh, you will hit the spring here. So what will happen? The A and B, it will move in different direction, right? So B will move to the left, to the right. A will move to the left. Okay. So the next one, adjust the position of the wooden block so that the two trolley hit them at the same time. Okay, and then you have to measure the distance D1, D2 respectively, okay, which are traveled by the trolley A and trolley B at the same time, same interval of time. Okay, so you have to adjust the position of the wooden block. Okay, so the trolley will hit the wooden block at the same time. Okay, so you have to adjust that one. Okay, and then you have to measure, okay, the distance, okay, D1 and D2. Okay, so mean you keep hitting, okay, until you can get the uh, you can get uh, the trolley here stop at the same time. Okay, you keep hitting and then you adjust, right? So maybe here they move high this they move longer time, this one shorter time, so this one you have to uh move it forward like that until you can get the same time desktop. Okay, right. For the number 2, describe the motion of the two trolley before and after explosion. Okay, so before the both trolley, okay, at rest. Okay, so before you hit the spring, okay, it will rest, right? The velocity is 0. Okay, then after you hit it, the both trolley move in opposite direction. So one move to the right, one move to the left. Okay, so before explosion, momentum trolley A is 0. Okay, since the V is 0, right, it's not moving, so means V is 0. The momentum trolley B also 0. Okay, so the total momentum, okay, trolley A plus trolley B, of course, 0. Okay, and then you have to compare the distance D1 and D2. Okay, so the distance should be equal. Okay, so this one you have to do the experiment. Alright, and then for number 4, state the relationship between the distance traveled by the trolley and the trolley velocity. Okay, so this one, the higher the distance, the higher the velocity. So this one is using this formula. V is equals to S over T. Okay, distance higher, velocity also higher. Right. And based on the diagram D, compare the velocity of trolley A and trolley B after collision. So since this one they got the distance is equal, right? So mean S is equal. Okay, so this one S is equal. Sorry, S is equal, so V also must be equal. Okay. And compare the momentum of trolley A and trolley B after collision. So it's become equal also. Okay, to become equal. Momentum trolley A after the collision, okay? So after the collision, since they move with the same velocity, and of course they have the same mass. So the momentum of trolley A and trolley B is same too. Okay, but the difference is they move with the different direction. So one should be negative. Okay, the momentum should be negative. Okay, so this one state the direction of motion of momentum trolley A through the right means MV. Okay, this one I mentioned just now, right? Momentum trolley B is negative. Okay, right. State the total momentum of the trolley A and trolley B. Okay, so MV plus M negative MV become 0. Right, so compare the total momentum before and after collision, also 0. Okay. So this one I will explain. Okay. So total momentum before, okay, total momentum after, correct? Okay, before collision, after collision. After collision. Okay, before collision, both of at rest. So means before collision is 0, correct? Okay, so after collision, one move to the right, one move to the left, okay, but it moves with the same momentum, right? Because the distance is same, means the velocity is same, right? And then the mass for two objects also is same, so means they both move with the same momentum, but one have a positive v, one has a negative v. So momentum for trolley A, since it moved to the right, okay, so the momentum is mv, okay, m plus positive m multiplied by positive v, okay. But the momentum trolley B is, since it moved to the left, okay, so m multiplied by negative v, okay. So that's why you get negative mv, okay. And then mv, okay, this one negative mv, so this one should be mv also. So 0. So mv minus mv is also 0. So that's why we said the total momentum before and after the collision is same. So this is the equation. Okay. This one. Okay, you can use this one also, but later then later you just change the position, but don't forget the negative signs. Okay, you get the same values. Okay, for exercise number 1. Okay, for exercise number 1. Okay, so this one is elastic. Okay, so how does we know this is elastic? So car A of mass 1000 kg, okay, moving at 20 meter per second, okay, collides with car B of mass 1200 kg, moving at 10 meter per second in same direction. Okay, okay, and then it said here, okay, if the car B is shunted forward, okay, is shunted forward at 50 meter per second, okay, at 50 meter per second by the impact, what is the velocity v of the car A immediately after the crash? Okay, so this one is a elastic, okay, because it didn't mention that the object move together or stick together. Okay, so this is the formula. Okay, so m1 is actually the mass for the car number 1 or car A here. Okay, and u1 is the initial velocity, okay, before it collides. So this one is 20. Okay, and plus m2 is the mass of the car B. Okay, so maybe you can place one here with A and B, so must be much easier lah. If not, you must be confused. Okay, so this one is 1200, while the u2 is 10 meter per second. Okay, equals to, okay, m1 is the mass of car A. Okay, so what's the question 1? The question 1, the velocity of car A. So means if want the final velocity of the car A. So 1000 multiplied by V. Okay, but the car B, right, they got the mass of 1200 and it moving with 50 meter per second. So you just substitute here. Okay, and then you got the value. So the answer is 14 meter per second. Okay. Right, so this one is much easier. So this is elastic collision. Okay, so this one, a 50 kg ball is thrown at a velocity of 20 km per hour, okay, to a 60 kg person who is at rest on ice. Okay, the person catch the ball and subsequently slide with the ball across the ice. So determine the velocity of the person and the ball after the collision. Okay, so the one person, it has a mass of 15 kg. Okay, alright, and then it's thrown a velocity of 20 kilometer per hour. Okay, the ball is 15 kg. Okay, the ball is 50 kg, is thrown at a velocity of 20 kilometer per hour to a 60 kg person who is at rest on ice. So means the ball is thrown to the girl. Okay, it's going to the girl. Okay, we has a 60 kg mass, right? And then after it catch the ball, okay, she catch the ball, okay, it moved along with the ball. So this one is actually inelastic, right? So inelastic is m1 u1 plus m2 u2, okay, equals to, since it move together, so now it become like one object. Okay, move together with the ball, right? So m1 plus m2 times v. Okay, but the problem here is you can see the velocity is in 20 kilometer per hour. So mean you have to change to meter per second. How to change? So 20 kilometer per hour, right? Okay, this one you already learned in form 1. So this one you have to change to meter per second. So 20 kilometer, you want to change to meter, you multiply by 1000. Okay, and then you divide by, so 1 hour is 3600, right? So you divide by 3600. Okay, so if you divide 20 times 1000 divide 316, you got 5.56, right? Take 2 or 3 decimal point. Okay, 5.56 here. Okay, so let's calculate. Okay, so the first one, the ball is 50 kg, right? So I took M1, U1 is the ball. Okay, so this is for the ball and this is for the person here. Okay, alright, so 15 U1 is we already calculate 5.56. Okay, plus, okay, the M2 here, the mass of the person is 60 kg and it's not moving, so U is 0. Okay, and then after it catch the ball, it moves like it's like with the ball. Okay, so mean is move together. So M1 plus M1, so 15 plus 16 here. 15 plus 16, and then you have to find the V here. So we just calculate 15 times 5.56, you get 83.4. Okay, so this one 0, no need. So 75V. Okay, so you just divide by 75, you will get 1.112 ms negative 1. Okay. Okay, this one they did not change. Okay, the answer did not change to meter per second. And it's wrong because, why? Because the answer is in meter. This one is kilometer, right? So you need to change first. Okay, so this one the answer is wrong. Okay, why? Because I already told you the answer here is in meter per second. This one is kilometer per hour, right? So this answer is wrong. Okay, so you have to change first. If not, you cannot use kilometer per hour here. Okay, so don't follow this answer. Okay, you just follow mine. Okay, the unit is not same. If you don't change, you cannot get meter per second. You have to change first kilometer per second to, kilometer per hour to meter per second. Then you can get the unit meter per second. Okay, so for number 3, okay, and also for the rest, right? I will let you try first. Okay, I will let you try first. Okay. Okay, so let's move on to the next part. Okay, activity 4. Okay, for the calculation, I will let you to try first. And then let's see, okay, if I will discuss it when the school open, or maybe I will make a video to discuss the question. Okay. Alright, so for activity 4, okay, to study the application of the principle of conservation of momentum. So what is the application? Why we need to learn the principle of conservation of momentum? Okay, so we can use the principle of conservation of momentum to explain, right? To explain many situations, okay, that happen in our real life, okay, or maybe in certain things, okay, let's say for the rocket, right? So we can use that to explain, and also for the balloon just now, right? Okay, and then this is a rifle. So, okay, so explain why a rifle recoil backward when it is fired, right? So when a rifle is fired, the bullet with mass m move forward with a high velocity. So when it move forward with high velocity means it has a high momentum and it move forward. Okay, so the forward momentum is produced. Okay, so a same momentum but in opposite direction, okay, is produced by the rifle to recoil the rifle backward. Okay, so this is the explanation for the rifle. So sometimes you can see when people using rifle, you can see they slightly move backward, right? The rifle slightly move backward. It's not very 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 high velocity. Okay, it's very low velocity. Okay, since because they cover it with the mass of the rifle is higher, right? So if the bullet, the mass is lower, so of course it will have the it has a high impact. Okay, than the rifle that moves backward, right? Okay, so that's the explanation for the rifles. Okay, next we see for the jet engine. Okay, so for the jet engine, okay, the fan suck air, okay, into a combustion chamber. Okay, so they have the combustion chamber here. So the inside the combustion chamber, okay, the air will compress. Okay, the air is compressed until it becomes hot. Okay, so we use the kerosene, okay, kerosene fuel, okay, in the jet engine. Okay, so the kerosene fuel will be injected to the chamber. So now they got the air, they got the kerosene fuel. So what will happen? Of course, the combustion will occur. Okay, so the explosion will occur and produce the high speed exhaust gas backward. So here is the combustion chamber. Okay, so here the air will go in and it will compress. Now it become hot, and then we inject the kerosene here, the oil. So the oil will mix with the air, it will produce the high velocity of hot gas here. So the hot gas will be moved backward here. Okay, so same as the rifle. Okay, so it will move backward, there will be produced the forward momentum. Okay, that move forward. So then it will move forward. So that's why the uh, the rocket can go up. Okay, so this is the explanation. And sorry to say for this one, for all the explanation, for all the application, you have to know, okay, you have to know because in exam there will be like a 4 marks, okay, in SPM, okay, for the AC part, right? Question number 9 or question number 10, okay, they have a 4 marks, okay, for the explanation. It means they will give you any situation or any application, then they will ask you to explain what happened. So you can see here they got 4 points here, right? So means 4 marks. Okay. Right. So this is the explanation. Okay, so this one is for the launching of the rocket. So the liquid hydrogen, liquid oxygen is mixed in the combustion chamber. So the mixture explodes. So this one I already explained. The hot gas move out the rocket nozzle at the high speed downward. Okay, and then they will produce the upward momentum that's same as the backward momentum. Okay, the force, the magnitude of force will be same. Okay, so that's all for the momentum. Okay, so I hope you can understand, right? And please do try to answer the question. Okay, so I see you in our next lesson. Right, so thank you class. Right, bye.